Hi children, welcome to another episode. As all of you aware of, this video is meant for those children who are writing the IIT advanced paper. And here we have a few questions. Concept is very important. Questions are pretty simple. Concept is very important, and in different way it may be presenting in front of you in the IIT exams. In fact, the 4 or 5 questions which we are going to discuss in this video, questions are pretty simple, but that content is very important. Okay, let's go through the questions. First one, the alkene formed as major product in the elimination reaction given below. You can see it is a quaternary amine given. It is a quaternary amine given which upon heating undergo elimination, and that elimination all of you are very much familiar with. It is in fact not in the syllabus, but many of you definitely have studied. It is called Hofmann's elimination. Hofmann's elimination. So when there is Hofmann's elimination, what are the possibilities? Look at the compound, and in fact this example also may be familiar to you. Look at the given molecule. We have a cyclohexane ring, and we have, there is methyl group given here. Okay, fine. So here we have nitrogen, which is the quaternary nitrogen atom. Here we have methyl group, and here we have ethyl group CH2 CH3, and the next is N-butyl group CH2 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 CH3, and this is a quaternary amine. And now this upon heating, what happens is you're going to get a one alkene, and the remaining part of the molecule will turn tertiary amine. That is what happening. So the point is whether the cleavage occurs when you heat the molecule, whether the cleavage is going to occur at point 1. Is it going to cleave over here, point 1? Or is it going to cleave over here, that is point 2? Or is it going to cleave over here, that is point 3? And there is no chance of cleavage here, as one carbon cannot give alkene. With one carbon you can't get a alkene, right? Now suppose it is cleaving at the first position. The possible product can be C and D. This can be the product. Whether you get a C or D, that is the point of discussion. It will be option C according to Seychef elimination. According to Seychef elimination, it will be compound C comes as a product, and according to Hofmann's elimination, it will be compound D, because Seychef elimination promote the most substituted alkene, while Hofmann elimination is generally promoting less substituted alkene. So that is most substituted, that is less substituted. So when it is cleaved here, either the double bond coming here or here. So it is coming here according to Seychef rule, it is coming here according to Hofmann's elimination. If cleavage 1 is happening. If cleavage 1 is happening, it can be either C or D. But C we can rule out, because out of C and D, this is the chance, as we are discussing the reaction of quaternary amine, which is promoting Hofmann's elimination reaction. Okay. Now, is it cleaved at 1? That is the question number 1. Now, suppose it is cleaving at number 2, you will get this is converted to alkene. The compound can be option B as the answer, because 2 carbon ethene. Now, if it is cleaved at the third position, you will get a 4 carbon butene. You get option A as the answer. There also a possibility that the molecule given this one or this one, this is 1 butene, this is 2 butene, 2 butene can be ruled out. It can be 1 butene if it forms. Now the question finally is where the cleavage occurs. Those who have gone through this kind of question definitely may be aware of, whenever you take a quaternary amine and try to heat it, And if the amine is probability of giving, is there any probability of giving ethene? That will be the major product. So no doubt it is cleavage occurring at the second position, and the alkene obtained will be, no doubt it is ethene is the alkene obtained. Option B is the correct answer. So if you deal with any quaternary amine heated undergoing Hofmann's elimination, the product obtained will be least substituted alkene, number one, according to Hofmann's elimination. And various possibilities of getting alkene like cyclohexene derivative, ethene derivative, ethene, butene, etc. If there is a chance of getting ethene, no doubt the answer will be ethene as the product. As in this case, the final answer is option B. Clear? Fine. Now on to next question. Before going to the next question, you can try of your own. You can try of your own what will be the product obtained. You can try of your own what will be the product obtained if pyridine undergoing exhaustive alkylation. Imagine this is treated with the excess of alkyl iodide, and upon heating you keep on continuing the reaction. This is piperidine or piperidine. Piperidine or piperidine treated with the excess of methyl iodide, methyl halide. Keep on heating and it undergo, you get a secondary amine turn tertiary amine turn quaternary amine. Upon heating there is Hofmann's elimination. Keep on doing that and try to get what is the final end product that you get. If you take piperidine taken for exhaustive alkylation followed by heating. This you can try of your own. This you can try of your own based on whatever we have discussed on the content of Hofmann's elimination. Fine, check it out. Next one. Next question. A compound with the molecular mass 180 is acylated with the CS3COCl to get a compound with the molar mass 390. The number of amino groups present per molecule of the former compound. So the compound contain amino group. The compound contain amino group. Say for example, if it is one amino group, just we don't know how many amino group, let it be one amino group, and it is interacting with the acylation. It is interacting for acylation reaction. You can see HCl out, and you get RNHCOCH3. So if one amino group present, you can see one acyl group is introduced. So number of acyl group introduced in the product depends on number of amino group present. So as many amino group present, as many acyl group in the final product, right? We don't know exactly how many amino group. That is a question. How many amino group is present? So the given compound is X having molar mass 180, and the obtained final product is Y, and that is having molar mass 390. And you see the molar mass is increasing. The molar mass is increasing due to acyl group. Molar mass is increasing because in each amino group one hydrogen is subtracted and one acyl group is introduced. What is the mass of acyl group? Acyl group, what is the mass? 2 carbon, 24, 1 oxygen and 3. So 24, 30, 40, 43 is the mass of acyl group. 43 is the mass of acyl group. And you see what is the difference? 180, 390. 180 plus 200 will be 380, 210. So the difference is 210. That is the difference in molar mass. And that difference is caused by acyl group. How many acyl group is coming? So it is 210 divided by 43. Approximate number, it is 5. 5. So there will be 5 amino groups present in X. If there are 5 amino group present here, 5 acetyl unit will be coming here. Because each amino group is getting acylated. If there are 5 amino group, there will be 5 acylation happening. For each acylation, molar mass increases by 43. And here the molar mass increase is 210 increase. So how many acyl group coming? 210 by 43. Approximately 5 acyl group coming. That means 5 amino group was present. Right? That is a quantitative estimation which I think all of you are aware of. Take it as a gentle reminder about a very beautiful, very important concept. Okay, next question. Here there is in fact a numerical question. 1 molar NaOH slowly added into 1000 ml 183.75 gram impure sulfuric acid solution and the following plot was obtained. The percentage purity of sulfuric acid. Percentage purity of sulfuric acid. So percentage purity of sulfuric acid, you can find out it is the mass of sulfuric acid divided by mass of impure sample 183.75 into 100. That will give you the percentage purity, right? Now, how much sulfuric acid is consumed? You can see 3 molar H plus, 3 molar NaOH is required. So concentration of NaOH, that is concentration of OH minus, is 3 molar. In fact, it is 1 liter solution. So it is 3 mole. So it is 3 mole. 3 mole NaOH. 3 mole NaOH, that is equal to 3 mole H plus, that is equal to 1.5 mole sulfuric acid. As all of you know, sulfuric acid is a dibasic acid. 3 mole H plus means it is 1.5 mole sulfuric acid, isn't it? So how much it is? 1.5 into 98 gram. So 98 plus 49. So it will be how much? 147 gram, isn't it? 98 plus 98 plus 49. 98 plus 49. 98 plus 50 is 148. 147. 147 gram is the mass of sulfuric acid involved in the reaction. And what is the mass of sulfuric acid taken is 183.75. So purity will be 147 by 183.75. It is approximately 1.418. 75, 80, 80. It is 75 or 80. 75 or 80. What about the slope? Slope is 3 by 3, 1. Slope is 3 by 3, 1. Minus 1 is the slope. Slope is equal to, very simple, slope is equal to minus 1. Slope is equal to minus 1 is only one choice, and that is the answer. And the percentage is 80% purity and the slope is minus 1. Right? And beautifully narrated question. Through this question, multiple content is actually tested. All of you know how that graph is analyzed and how you get that data and how you go for the purity calculations. A typical question for the exam purpose. Fine. Next one. And that in fact is the last question. Today's video. In this video, this is the last question. When 1 mole pure ethyl alcohol mixed with 1 mole acetic acid, the equilibrium mixture contains 2/3 mole each of ester and water. Delta G for the reaction is simple, no? Delta G will be minus 2.303 R T log Kc. So once you get Kc, you get the answer. So this is taken 1 mole. this is taken 1 mole, 0, 0. At equilibrium, this is 2 by 3. Obviously, this is 2 by 3 and this will be 1 by 3 and this will be 1 by 3, isn't it? 2 by 3 converted, 1 by 3 remaining. So, Kc will be 2 by 3, 2 by 3, 1 by 3, 1 by 3. You get 4. Kc will be 4 and that's over. That's over. Delta G naught is equal to minus 2.303. We want answer in joules. So let me give 8.3. Temperature given 298. You can take it as 300 into log 4 into log 4. Log 4 is 2 log 2. Log 4 is 2 log 2. 2 into 0.3, 0.6. 0.6. So this will be 0.6. So 2 into 8, 16, somewhat 20. 20 with the 300, 600. So it is 3000 something. 3000 something. It should be minus. It should be minus and the answer should be 3000 something. Option B is the correct answer. Very simple, direct application of a formula, right? So that's about the questions in today's video. In fact, the questions are very simple, but I would like to have every children go through that conceptual area, and many of you might have gone through that. If you have missed that area, please review, and with more of questions, probable questions, and a possible conceptual repetition that can happen. In normally IT exams, questions never repeated. Questions never repeated means as such the questions is not repeated. Concept is many times similar concept they try to introduce, but the way the question is presented, you can see it seems to be entirely new idea, right? So understanding the concept and reviewing that concept clearly and recollecting that idea is very, very important, which comes only by practice and comprehension power, right? Try to build up that. We will meet with another beautiful set of questions in the next video. Till then, bye, take care, see you.